Hello there, welcome back to P.O.D. Officials. Today we are here to talk about circle theorem under the strand measurement. Okay, so let's dive deep into it. So you can see from the diagram that this area is called a sector, and the sector is the area between two radii. And we also have the radius, and the radius is the distance from the center to any part of the circumference. With this one, it touches the circumference at this direction. This one too touches here, so they are all radius. From this center to here too is a radius. From here to here is a radius. From here to any part is also a radius. Now let's talk about the circumference. So the circumference is more or less the perimeter of the circle. So we use perimeter for other figures like quadrilaterals, triangles, and the rest. But when it comes to circle, we use circumference for that. And we also have the diameter. Diameter is 2 of the radius. So when we add 2 radius, we get what? A diameter. And it is the distance from one point of the circumference passes through the center of the circle and touches the other side or another part of the circumference. So always passes through the center. Okay, so we also have a chord, and mind you, the diameter is also a chord. A bigger chord is the bigger chord you can get in a circle. Now we have other chords, and this chord, a chord is any distance or any line that touches a circumference on two sides, or it joins 2 points on a circumference. Let's put it that way. And we have a segment. A segment is the area between a chord and an arc. So you can see here is an arc, and this is a chord. So the area between the two of them gives us a segment. Now let's talk about an arc. An arc is any part of the circumference. So an arc falls exactly on the circumference. It's part of the circumference. So in due time, we'll be talking about how to calculate for circumference, how to calculate for area of a circle, how to calculate for the minor arcs, the length of a minor arc, how to calculate for the area of a sector. But today I would want us to talk about the radius, how to calculate the diameter and circumference if a radius is given. And when you take pi to be 22 on 7, before I go to this example to solve it with you, I would want us to talk about the pi. So the pi is a Greek letter that we represent it when it comes to circle theorem. So how we managed to get the pi is this. The pi is approximately 3.14159 approximately. So when you say something is approximately, it's not exactly equal to. So, and it continues, it has a lot that it doesn't end and it does not repeat itself. The figures does not repeat itself. But this is how we go about it. If you can gather in any circle or cylindrical objects like the milk can, like the Milo cans, and any circle ones, and you use tape measure, the flexible one, to measure the circumference. I mean how circular the thing is, the circumference of it. Put the figures down or the data down, then calculate the diameter. Make sure you put it, the ruler or the tape measure, exactly in the middle, the center of it, and measure the diameter. After getting that, now the circumference you get, the circular part, divided by the diameter you had, you realize that you get 3 point something. Do you get it? 3 point something. And that 3 point something might look exactly like this. You realize that you get the pi from this kind of measurement, the circumference divided by the diameter. That's how we get our pi. And we normally approximate it because pi itself is an irrational number. When you say irrational number, it can be simplified in common fraction, as in we have 1 on 2 or half, we have 1/3, 1/4. We can't put it in that cases, so it's an irrational number. So when we want to use it in decimal form, we then cut it off as in 3.14. so you can try them at home. You can pause the video, go and look for cylindrical objects, find a tape measure and a ruler, make sure you measure the circumference of it well, put down the data, measure the diameter, make sure you put it in the middle. I told you the diameter passes through the center, so make sure you put it in the middle, measure it well, and divide the circumference by the diameter. And you realize, so I made mention earlier on that pi is an irrational number, so we can't put it in simple fraction like 1/2, 1/3, or 3/4 or something like that. But someone will ask, why then do we put it 22 on 7? 22 on 7 in the sense that when you have a calculator, you key 22 on 7 and you turn it to decimal, the answer you get is equivalent to the 3.14159 I was talking about. So approximately they cut it off to 3.14. That is why we usually use 3.14 in terms of decimal when we want to use the decimal one and we don't want to use 22 on 7. So right now I'll proceed in solving this example with the radius of a circular object is 28 centimeters. Find its diameter and circumference. Take pi to be 22 on 7. So in the question entails two answers. The first one is we are finding the diameter, and the second one is circumference. So with the diameter, they said the radius is what? 28 centimeters. And we all know that diameter, 2 of the radius makes what? The diameter, 1 diameter. So with this, we then make a statement that we represent diameter with d. So d is equal to 2r. 2r in the sense that r plus r. Or let me put it this way. R plus r, which is what? 2r. So in this sense, our r is equal to 28 centimeters. So it implies that our d equals 28 centimeters plus 28 centimeters, which will be 56 centimeters. Or we then our radius, our diameter becomes 2 times our radius, 1 of it. So let me do it this way. 2 times, and our radius is 28 what? Centimeters, which is still 56 what? Centimeters. Now we are done with our first question. Now we move to the next one. They say we should find our circumference, and the circumference we have 2 ways. Using the diameter, circumference, which is c, is equal to pi d. If we are using the radius, that one to be 2 pi r. And mind you, this is the difference. D is equal to 2r. So that is why we have this 2 and we have r here. So it's the same as this. In mathematics, always the number becomes the coefficient. So even if the number appears in the middle, we have to push it in front so that it becomes the coefficient. That is why the 2 that is attached to the r have moved in front. So that was the reason why in terms of radius it becomes 2 pi r, and in terms of diameter it is pi d. So I'll solve with this, the 2 of them, and we know our answers. So when it comes to with the first one, when it comes to our pi is 22 on 7. when it comes to our D, is 56 centimeters. So our circumference is equal to pi is 22 on 7 times the D, 56 centimeters. Now we then check whether 7 can divide the 56. So 7 49, 7 8 56. So 7 8 is what? 56. So 7 will cancel itself 1 and cancel 56 8 times. Now 8 times 22. We have 8 to 16, 6 carry 1. Another 8 to 16 plus 1, which is what? 17. And the unit, don't forget. So the answer is 176 centimeters. So this one to all, we have C is equal to, we know our radius. With this one, we know our radius too is what? 28 centimeters. With the same, we have our C is equal to 2 times 22 on 7 times 28 centimeters. And with this one too, 7 cancel itself 1. 7 2 14, 7 3 21, 7 4 28. So 7 4 is what? 28. Now we have 2 times 22 times 4 centimeters. And 2 times 22 is 44. So you have 4 times 4 centimeters. Now 4 times 4. 4 is what? 4 is 16, 6 carry 1. Another 4 is 16 plus 1, 17 centimeters. And that was how we had our answers. And so, thank you for also tuning in for today's lesson. And as I said, I'm your sir, Isaac, and I want you to subscribe, like, share, and also comment. We need your comments. We need them so that we can make these lessons very nice for you. So thank you once again. Bye.